All right, this video is in regards to section 1.7, which involves problem solving. Problems involving interest, mixture, uniform motion, constant rate, and job applications. First, let's discuss how to translate verbal descriptions into mathematical expressions. Let's translate these verbal descriptions into mathematical expressions. For example, a rate formula. Another word for rate is also the speed of an object. So the average speed of an object, r, equals the distance traveled divided by the time required. So again, the average speed of an object, r, equals the distance traveled divided by the time required. So this formula, R equals D divided by T, is the formula for rate. A car that travels a certain number of miles per hour, you could see miles would be the distance, the number of hours it takes to get there would be the time. We could also rewrite this formula in terms of D. Right now, this formula is solved in terms of R. But if we wanted to rewrite this formula in terms of D, all we would have to do is multiply both sides of this formula by T so that the T's cancel out. So we would have D equals R times T. That's another way of writing the same formula, but solved for D. If we wanted to rewrite this formula in terms of T instead, all we would have to do to get T all alone on one side of the equation is to divide both sides by R. So let's divide both sides by R, and we get T equals distance divided by rate. So it's the same formula written three different ways, depending on the item that is unknown in your problem. Let's look at a different example. This time, let's talk about simple interest. The simple interest is the interest that is paid, I, on a loan that is equal to the amount of the principal times the rate of the interest expressed as a percent times the period of the time in years. So let's go ahead and put that into an equation, a simple interest equation. So what we would do first is we see that simple interest is equal to the uppercase I. Since the simple interest I is equal to the amount of the principal P times the rate of the interest expressed as a percent times the period of time in years. So I equals PRT is a formula for simple interest. We will use that formula on the next page in an example. There are also other formulas. Geometry offers a lot of formulas that we would also use. For example, perimeter. Perimeter of a rectangle is equal to twice the length added to twice the width. So we could say perimeter of a rectangle equals twice, which means 2 times the length, added to twice or 2 times the width. We could also write the area of a circle as the product of the number pi and the square of those units. So let's write an equation for this one. So we have area of a circle is the product of, so that means we're going to multiply, because the product means multiply, the product of the number pi and the square of the radius. So area equals pi r squared. A physics example would be force equals the product, so that means multiply, of mass and acceleration. That's another example of writing a verbal description as a mathematical expression. So let's take it one step further and let's go ahead and write it as an equation, but then also solve it. In this example, we're writing the verbal description as a mathematical expression, and then we will solve it. So let's go ahead and write this as a mathematical expression. So we have twice a number, we're going to let x equal the number, added to 3 is equal to the square of the number. So we have taken that verbal description and written a mathematical expression for it. But now it asks us to go further and solve this. This is a quadratic. Whenever you have a quadratic equation, back from chapter 1.2, we always set quadratics equal to 0. So what we're going to do is we're going to subtract everything from this right side, and we're going to move it over to move it from the left side to the right side. So this becomes x squared minus 2x minus 3 equals 0. This is factorable. This is the preferred method. You could use quadratic formula in its place. This is x minus 3, x plus 1. So that means x could be 3, or x could be negative 1. So there are two answers to this problem. Moving on to the next page, we're going to do some more word problems. But first, let's look at some expressions on how we can go through this using steps. In the steps I've written here, it says first read the problem, and sometimes more than once. What is the question or the thing you're trying to find? Define this as your variable. A lot of students like to use the letter X, but feel free to use any letter that makes sense in the context of your problem. For example, you could use I for interest. Use only one letter. Try to write the other unknowns as an expression of the first. So only try to use one letter if possible. Make a list of all your known facts. Make expressions if possible. Can you draw a picture to help you? Estimate what you think a best guess answer would be if it's feasible to do so. What would be an absurd answer? Make an equation and solve for the variable. Answer the question from the beginning. This is different than solving an equation. And then check your answer with the facts of the problem. Is it reasonable? Let's look at a rate problem. Johnny just got his driver's license and went on his first road trip to Nashville, Tennessee with some friends. He left home at 2 p.m. and arrived at 8. He texted his mother when he got there. His mother thought that that was too quick of a drive and he must have been speeding. She found out that Nashville is 439 miles from her house. Should Johnny's mom be concerned? So back up to the instructions that we had up above. First, read the problem more than once. So now's a good time to pause the video and read the question one more time at your own speed. Once you're done reading it again, ask yourself, what is the thing that you're trying to find? Usually it's the last sentence in the question. Right here it says, should Johnny's mom be concerned? Well, what is she concerned about? She thought it was too quick a drive, he must be speeding. So she's trying to find out if Johnny was speeding. In other words, she's trying to find his rate. We're looking for the rate. So in this case, R, which is the rate at which Johnny is traveling, and is that rate too fast for the speed limit? So that's what we're trying to find. We define this as the variable we're looking for. Let's list all of the known facts. What do we know? The first thing we know is it took them 6 hours to get to Nashville. So we know that the time was 6 hours. What else do we know? Well, Johnny's mom Googled how far it is from her house to Nashville, and she found that it should have taken him 439 miles, which is the distance. Can you draw a picture to help? Sure, I guess in this case we could draw a picture. So down here, let me draw a picture. We have Johnny's house. Maybe it's in Valparaiso, Indiana. And he left in his car and he drove to Nashville. We know that that distance is 439 miles, which is also equivalent to 6 hours apart. What we're looking for is the rate at which he was traveling. What is a best guess? Okay, now you're just guessing at this question. You're traveling from here to Nashville. It took him about 6 hours. So a good guess for the rate would probably be something around a speed of 50, 60, 70, 80 miles per hour, something like that, right? I mean, clearly he's not driving 10 miles per hour and he's not driving 100 miles per hour. It's going to be something around what the speed limit is. So I would guess something around 50 miles per hour up to maybe 85 miles per hour. I'm sure he could go faster or slower than that, but that's likely going to be around where my answer should be. So if I find something that's not in that range, I know that that is going to be what's called an absurd answer. Okay? An absurd answer in this case would be something that is not in that range. Certainly any negatives would be an absurd answer, or anything greater than 100 miles per hour would also be an absurd answer. Most cars do not travel that fast, especially on average. So let's go ahead and make an equation and try to solve for the missing variable, which is r. Well, remember from the previous page, we do have an equation that puts r, t, and d all together. Now we're solving for r. So we're going to pick from the first page. If I put those back into focus, I want to pick the one of these three equations that solves for r. In this case, the item I'm looking for is r, so I want to use this one for my equation. I already have d, I already have t, so I want to plug those in to find the missing variable in this case, which is r. So I'm going to use r equals d divided by t. So we have down here r equals d divided by t. So in this case, d is 439 miles and t is 6 hours. Now, if I divide those in my calculator, I get approximately 73.2 miles per hour. Miles per hour. So if I finish the question, I solved for the variable. I did find what r is. But now answer the question. The question was, should Johnny's mom be concerned? The question wasn't, how fast is Johnny going? The question was, should Johnny's mom be concerned? So make sure you answer the question that is being asked. I guess this answer would depend on what the average speed limit was on the way down there. Regardless, 73 probably is speeding. So yes, Johnny's mom should be concerned. This is an average speed, which includes stops, potty breaks, gas breaks, and so on. If the average is already above the speed limit, I think Johnny's mom should be concerned. Let's try another one. This time let's do an interest problem. Here we have Juanita. She borrowed $500 for 6 months at a simple interest rate of 9% annually. What is the interest that Juanita will be charged on the loan? How much does Juanita owe after 6 months? So in this question, we actually have two questions that we need to answer. First, let's focus on the first question. So the question that's being asked is, what is the interest that will be charged on the loan? Well, if you remember from the first page, we did come up with a simple interest formula, which was I equals PRT. What do I know from this question? $500 is the amount of the principal, so P is $500. I know the time frame is 6 months. But generally, time should be written in years. So we don't want to leave time in terms of months. We want to write time in terms of years. So we're going to write this as 6/12 years, which obviously is a half of a year. Or you could call it 0.5. We also know the annual rate. The annual rate is 9%, but in this formula, we want to write this as a decimal. So I'm going to write this as 0.09. I have P, R, and T, which is everything that I need in order to solve for what the interest is, which is indeed the very first question. So let's go ahead and type everything in. P is 500. R is 0.09. And T is 0.5 years. So when I plug all of that into my calculator, I have, I'll put this over here, 500 times 0.09 times 0.5. So the amount of interest that will be charged to her is going to be $22.50. Remember, this is money. So rounding it to the nearest hundredth is the only appropriate place to be rounding these numbers to. Showing any additional decimals after that would not be appropriate, as the penny is the smallest monetary unit. So the second question now, this answers the first part. The second question says, how much does Juanita owe after 6 months? So she borrowed the $500. She clearly has to pay back the principal. So she will owe the amount of the principal, which is the $500, plus the amount of the interest that has accrued on her loan. So Juanita will owe back to her person that she loaned from the $500 plus the interest. So she will have to pay back $522.50. Let's look at some more complicated examples on the next page. Candy has $70,000 to invest and wants an annual return of $2,800, which requires, which requires an overall rate of return of 4%. She can invest in a safe government-issued certificate of deposit, but it only pays 2%. To obtain the 4%, she agrees to invest some of her money in non-insured corporate bonds that pay 7%. So how much should be placed in each investment to achieve her goal? So the first question I ask is, what is being asked to find? Well, there is the question at the very end right here, and it says, how much should be placed in each investment? This is the question. And when they talk about each investment, we are putting money into the government-issued certificate of deposit, but we also are going to put money into a non-insured corporate bonds. So each investment, we're looking for how much money should we put into the CD, and then how much money should we put into the bonds. Now, the bonds do carry a higher interest return, but they're also more risky. So that's why she wants to diversify and putting money into a CD, which is less risky, but also earns less amounts of interest. So let's define our variables. Okay, we have two things here, and we're going to define both of those variables. Let's let X equal the amount in dollars that we'll invest in, let's call bonds. In fact, why don't we change the letter? Let's call it B for bonds, okay? It might help make the letters coincide with what you're trying to find. So let's let B equal the money invested in bonds. And it doesn't matter which one you pick to start with. Now, I know she wants to invest $70,000 in total, right? So over here to the side, really quick, let me do a little calculation. I know the amounts in the CDs plus the amount in the bonds is going to total $70,000 because that's how much money she total has. So if I wanted to solve for CDs, right? Okay, if I wanted to solve for CDs, I know that the amount she wants to put in CDs is going to be equal to $70,000 minus what she puts in bonds. So look what I did there. So the amount that she plans to put in the CDs is actually going to be equal to $70,000 minus what she puts in bonds, which is going to be the money invested in CDs. So I'm not actually using a different letter. I'm using the letter B for bonds, but I'm also using the same letter B in a new mathematical expression for the amount invested in CDs, because we know that the two of these have to add up to $70,000. So what are the facts, right? The facts are that bonds are going to yield a return of 7%. And we know CDs are going to yield a return of only 2%. But she desires a return of 4%. So we got to make a mixture of the two of these in order to create a return of 4%, which is in between there. Now, if I were to make a best guesstimate, I would not say they're going to be equally split, because this 4% is not equidistant in between those two numbers. 4% is closer to 2%, which means we will need more of the bonds than less of, more of the CDs than less of the bonds, because again, we want a percentage that's going to be closer to this interest rate, which is 2%. So I don't think this $70,000 is going to be split equally between bonds and CDs. We will put majority or more than half towards the CDs and less than half towards the bonds. That's a rough estimate. So maybe something like 40 grand to the CDs and only 30 grand to the bonds. So let's make a picture. In this case, it's going to be a table, which will help us in deciding how to create an equation. Well, I know that the principal I put into bonds is going to be the letter B, because that's what I labeled it as up here in our variables. And the amount for CDs we decided was going to be $70,000 minus, well, whatever I put towards bonds. We'll put in the bonds first, and then whatever's left over will go towards the CDs. And obviously, when I add these two items up, that makes the $70,000 in total that Candy has to put into her accounts. Now, the rate of return for both of those, for bonds, is 7%, and for CDs is only 2%. But I know when I add those up, I want to make sure I get 4%. The time I need to invest these, if I go back to the equation, she wants to invest for just 1 year. So we're going to invest for just 1 year for each of those. So let's find the interest, and we know the interest formula, which is PRT from the previous examples. So we're going to find the interest, which is P principal times R rate times time. So it's going to be B times 0.07 times 1. Well, that's just 0.07 B. The interest I'll earn on the CDs is going to be the principal of 70,000 minus B times the rate times the time. So I'm going to multiply these two things together, which is going to give me 0.02 times 70,000 minus B. So then, of course, when I add these two items up, I want to get a total of 4% of my investment. Well, 4% of $70,000, I put that in my calculator, and I find 4% of $70,000 means she'll get a rate of return of $2,800. So she's looking for $2,800 as a return out of an investment of both of these here. So these two things should add up to $2,800. So that's what I need to do in order to make the equation and solve down here. Remember when I estimated the answer earlier, I decided the amount in bonds and the amount in CDs. CDs was going to be a little bit more than bonds, so I'm going to estimate CDs to be roughly $40,000 and bonds maybe around $30,000. It's just a guess. But I know CDs has to be a little bit more than bonds, and I know they have to add up to $70,000. So if I get an answer that's way off from that, I know I'm wrong. Remember what an absurd answer would look like. An absurd answer would be something that does not add up to $70,000 or an answer that's negative or more than $70,000. We definitely want to stay away from those. So let's make an equation and now solve. Since I know that both of these interests up here have to add up and total $2,800, that's going to be my equation. So I have the amount of interest I'll earn from the bonds plus the amount of interest I'll earn from the CDs has to total $2,800. And now let's solve. So let's distribute and get rid of the parentheses. So 0.02 in my calculator times $70,000 is going to give me 1,400 minus 0.02b. So all I did was distribute that 0.02. So now let's add the like terms. So that gives me 0.05b plus 1,400 equals 2,800. Let's subtract the 1,400 from both sides. So that gives me 0.05b equals 1,400. And then, of course, we'll divide both sides by 0.05. And that gives me that the amount that'll be in the bonds is 1,400 divided by 0.05, which is about $28,000. And I like that answer because look how close it was to my original estimate that I made earlier. So I feel very confident that I've done the right thing in solving this equation here. Okay, so I've solved the equation, but now I got to go back and answer the question. Let's go back to the beginning and find the actual equation. Remember, the question that is being asked is how much should she place in each investment? So not just the bonds, but also how much should she place also in the CDs? So we got to answer both questions. So we know that Candy should put $28,000 in bonds. But we also have to calculate how much she should put into the CDs. Well, remember, CDs is a total of 70,000 minus the bonds. Remember, she has to total 70 grand here. So let's subtract that number from 70 grand. That gives me $42,000. So that's how much Candy should put into her CDs. Candy should put $42,000 in the CDs. And I think that's a relatively accurate number because it does match closely to what our estimate was earlier. There should be more in CDs than there is in bonds, and they total $70,000.